Guys, welcome to Science Learning Gateway. I hope you all are doing good. So, in this tutorial, we are going to discuss Class 10 Science Chapter number 5, Periodic Classification of Element. And in this chapter, we are going to revise this chapter in a very simple way so that we can complete the chapter in less time. Like this, we are going to start the revision from all the lessons in one shot. Means in one tutorial only we are going to cover the full chapter so that it will be helpful for you also during the exam to prepare for it and you can score a good marks. So let's start with the lesson. I have already uploaded a video for chapter number 5, periodic classification of element. In that I have explained the chapter in detail. The notes are covered from your NCERT science textbook. You can check that in the playlist of class 10. So let's start the revision from chapter number 5, periodic classification of elements. As you all know, there are 118 elements in the periodic table. Correct? How many elements are there? There are 118 elements. Out of 118 elements, 98 elements are naturally occurring. But what was the need of classification that time? As in this chapter, what we have to read? Periodic classification of element. So what was the need of classification? See, the need of classification is that there are so many elements, correct? 118 elements. It's not not possible for us or even for the scientists to read the properties of each and every elements individually. That's why they are grouped according to their similarities and dissimilarities. That's why classification was needed. What was the basis for classification? Elements with similar chemical and physical properties are grouped in one group, one period, and according to that the elements were classified in the periodic table. That was the basis for classification. As you when you go to the shops, you can see over there that different varieties of soaps are there. Soaps and detergents are there. Even they will separate the bathing soaps, they will separate the cleaning soaps in different shelves, so you can easily pick up whatever you need. Like that only in periodic table the elements are grouped according to their similarities and differences, so that if one element in a particular group we will read, we can know about the properties of the other elements also. So that was the basis for classification of elements. You can see in this periodic table there are so many elements. The elements which are present on the left hand side of the periodic table, they are known as metals. Metals are present on the left hand side of the periodic table. A zigzag line which you can see over there. A zigzag line which you can see over there, the green color line. These are the metalloids. What are metalloids? Metalloids are those elements which have some properties of metals and some properties of nonmetals. Examples of metalloids you can write boron, silicon, germanium, arsenic, antimony. 2-3 examples if you learn for metalloids, it will be enough for you. Generally questions are asked from this section also. What are metalloids? Give example. So you can write metalloids are those elements which have some properties of metals and some properties of nonmetals. Example boron, silicon, germanium. To the right of the metalloids we have nonmetals. Nonmetals. So you can easily remember that metals are present on the left hand side of the periodic table, nonmetals are present on the right hand side of the periodic table. A zigzag line separates metals from the nonmetals and they are called metalloids. They are called metalloids. Over there you can see at the bottom lanthanides and actinides are separated. They have been given a different place in the periodic table, and in total we have 18 groups. 18 groups are present over there and 7 periods are there. The vertical columns which you can see over there, they are called groups, and horizontal rows which you can see over there, these are called periods. So how many groups are there? 18 groups are there and 7 periods are there in the periodic table. This is called modern periodic table. So let's start with our discussion. See, different scientists were there. They have given their views for the periodic table, means how elements are classified, and according to that. The first of all, we'll read about Dobner's triad. When elements were arranged in order of increasing atomic masses, this is very important, that according to Dobner, the elements were arranged according to their increasing atomic masses. Groups of 3 elements known as triads. Triad means 3. So 3 elements were arranged according to to their increasing atomic masses, having similar chemical properties are obtained. When what Dobner said, that when he arranged three elements in the order of increasing atomic masses, three elements were arranged, okay, and all of them, they were having similar chemical properties. And what he concluded next, that the atomic mass of the middle element was roughly the atomic mass of the average of the other two elements. Suppose you have three elements A, B and C. So the if you take the average of the atomic masses of A plus C, the atomic mass which will be obtained will be roughly equal to the atomic mass of the element B. For example, over there you can see three triads are there: lithium, sodium and potassium. So if you add the atomic mass of lithium and potassium and you will take the average, you will get the atomic mass of sodium, that is 23. So this was the concept of Dobner's triad. What he did, Dobner arranged three elements in the order of increasing atomic masses, and he found that the atomic mass of the middle element was the average of the atomic mass of the other two elements. Now, there were some limitations also at Dobner's triad. So what was the limitation? The first limitation was only three triads were recognized from the elements known at that time. That time very less elements were known, and in that too also Dobner has found only three triads. The first triad was of lithium, sodium, potassium. The second triad was of calcium, strontium and barium, and the third triad which he identified was of chlorine, bromine and iodine. Only these elements were known at that time. Only 9 elements he got. He studied the properties about these elements only. The other elements he couldn't do anything for the other elements. Now the second limitation was he fails to arrange all the known elements in the form of triads, even having similar properties. Means the elements which were known at that time also, he could not arrange those elements in the form of triad. He could not study their properties also. Only these elements he studied, and he has given his ideas about these elements. Now after Dobner's triad, then again a new scientist came up with his ideas, and the name of that scientist was Newland octaves. So according to Newland law of octaves, when elements were placed in order of increasing atomic masses, he also placed the elements on the basis of increasing atomic masses. He arranged them on the basis of increasing atomic masses. The physical and chemical properties of every eighth element are repetition of the properties of the first element. Suppose we have 8 elements: A, B, C, D, E, F, G, H. So this is the eighth element. The property of eighth element will be similar to the property of the first element. Means the properties of A and H will be similar. So according to Newland's law of octaves, he arranged the elements on increasing atomic masses, and the property of the first element was similar to the property of the eighth element. This was his concept about the elements. After that, he compared this to the octaves found in music and called it the law of octaves. Means you have heard about the musical notes sa re ga ma pa dha ni sa. Over there, the eighth tune will be similar to the first one. So he has observed the same thing when he arranged the elements, that the first element is having similar properties of the eighth element. So for example, the properties of lithium was similar to that of property of the sodium. Lithium, atomic number 3, is having similar property with the element sodium, atomic number 11. Their properties are similar to each other. Now, after going through this, many limitations were also there in Newland's law of octaves. So let's have a quick look on the limitations of Newland's law of octaves. It was applicable only up to calcium, only for lighter elements. Means Newland's law of octaves can be applied to the element calcium, not more than that. Only till calcium, only for the lighter elements it is applicable. Second one, according to Newland's, only 56 elements existed in nature and no more elements could be discovered in the future. What he said, that only 56 elements are there in nature, and after 56 elements, no new elements cannot be discovered. But now we know that there are 118 elements. So this was also one of the failure of Newland's law of octaves. But later on, several new elements were discovered whose properties did not fit into law of octaves. Many elements were discovered after that also, and their properties was not fitting in the Newland's law of octaves. Next one, Newland adjusted two elements in the same slot. Example, cobalt and nickel are in the same slot, and these are placed in the same column as fluorine, chlorine, bromine, which have very different properties than these elements. Okay, one more mistake what he did is that cobalt and nickel, he placed these elements in the same slot and in the same column along with the halogens fluorine, chlorine, bromine. But we know that the properties of cobalt and nickel are completely different from the halogens fluorine, chlorine, and bromine. So this is also one of the limitation of Newland's law of octaves. Now, after Newland's law of octave came the third scientist, and his name was Mendeleev. So now we will be reading about Mendeleev's periodic table. According to Mendeleev, when elements were arranged in order of increasing atomic masses, he also arranged the element on the basis of increasing atomic masses. The elements with similar properties occur at regular intervals. What he said, that when he arranged the elements on the basis of increasing atomic masses, the elements with similar properties occur at regular intervals, means some properties will be similar among the elements. The properties of elements are periodic function of their atomic masses, and this is the law. This was a statement which was given by Mendeleev. The properties of elements are periodic function of their atomic masses. Mendeleev's periodic table is based on chemical properties of elements. It contains 6 periods and 8 groups. Okay, when he arranged the elements on what basis? On the basis of increasing atomic masses. And according to him, how many periods were there? 6 periods are there and 8 groups were there. Merits of Mendeleev's periodic table. Now, this Mendeleev's periodic table, it is having some merits also and some demerits also. So let us read about the merits first. Some gaps were left for the undiscovered elements like gallium, scandium, and germanium. When he prepared Mendeleev's periodic table, he left some spaces for the undiscovered element like gallium, scandium, and germanium. It predicted the properties of several undiscovered elements on the basis of their position in the table. Okay, many elements were not discovered at that time, but he predicted their properties on the position he left in the table. Noble gases could accommodate in the Mendeleev periodic table without disturbing the periodic table after discovery. Noble gases were not discovered at that time, but they can easily fit into the Mendeleev's periodic table without disturbing the other elements. Now we will have a look on the limitations of Mendeleev's periodic classification. Position of hydrogen atom was not correct. Means hydrogen has not got the proper position in Mendeleev's periodic table. Position of isotopes were not decided. Example, chlorine 35 and chlorine 37. Their position was also not decided at that time. Position of some elements with lower atomic masses before with higher atomic masses. See, over there you can see nickel is having atomic mass of 58.7 and cobalt is having atomic mass of 58.9. But then also the nickel was placed first and cobalt was placed less, but after that. But Mendeleev said that that elements were arranged in the order of increasing atomic masses, but this concept was not clear for him. So this was one of the limitation which was faced by Mendeleev. Now, after Mendeleev's periodic table, we have to read about modern periodic table. The periodic table which we are using these days, it is modern periodic table. In 1913, Henry Moseley showed that atomic number Z of an element is a more fundamental property than its atomic masses. What Henry Moseley said, that the elements can be arranged according to their atomic number, and it is also important property as compared to atomic masses. We represent atomic number with Z and atomic mass with A. So according to Henry Moseley, atomic number is more fundamental property than atomic masses. Modern periodic law. This is also one of the important question which can come for your exam. State modern periodic law. So what you will write over there, that it states that properties of elements are periodic function of their atomic number. Properties of elements are periodic function of their atomic number. But in Mendeleev's periodic table, what we have read, properties of elements are periodic function of their atomic masses. Just over there you have to you have to add atomic number. Now what is atomic number? Atomic number is represented with a letter capital Z and is equal to number of proton present in the nucleus of an atom of an element. How many protons are present in the nucleus? That is called your atomic number. And in an atom, always number of proton is equal to number of electrons. So atomic number Z can also be equal to number of electrons. All the limitations of Mendeleev periodic table disappear. After the discovery of modern periodic table, the limitations which we have read in Mendeleev's periodic table, they disappear. Now we don't have any limitations which we can see in modern periodic table. Now first of all, we will be reading about position of elements in the periodic table. Okay, so in modern periodic table, how many vertical columns we have? We have 18 vertical columns and they are called groups. And how many periods are there? There are 7 horizontal rows and they are known as the periods. Elements with same number of valence electrons are placed in the same group. Means we have 18 groups. So in every particular group, the elements which are present, they will have the same valence electron. For example, in group number 1, whatever elements they are, they will have the same valence electron. Valence electron means outermost electrons, the electrons which are present in the outermost shell. So all the elements will have one valence electron. The elements which are present in group number 2, they will have 2 valence electrons. For example, you can see the electronic configuration of chlorine. Chlorine is having atomic number 17. If we write its electronic configuration, it is 2, 8 and 7. So this chlorine is present in group number 17. Okay, and fluorine, if you take the example of fluorine, 2, 7. These all elements have 7 valence electron in their last shell, in the outermost shell, and they all are present in group number 17, halogens. Number of shell increase as we go down the group. When we move from top to bottom in a group, number of shells increases and hence atomic size of the elements will also increase. But when we move in a period, what will happen? The atomic size of the elements decreases that time. So remember that when you go from top to bottom in a group, atomic size of the element increases and what is the reason? Number of shells increases. But when we move from left to right in a period, atomic size decreases. Elements with same number of occupied shells are placed in same period. Yes. Now how we can predict that which element is present in which period? Suppose if all the elements are, suppose an element is having 2 shells, K and L. So it is present in the second period. Suppose an element will have only 1 shell, that is K shell. So that element will be present in the first period. So number of shells tells you about the period of the element. Suppose the element is having 3 shells, K, L and M. So this element will be present in the third shell. Suppose the sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon, they all are having 3 shells, K, L and M. So these elements are present in the third period because they have 3 shells. They have 3 shells in their atom. Maximum number of electrons that can be filled in a shell is given by 2n square. Okay, now one rule is there by which we can predict that in one shell how many electrons can be present, and that formula is 2n square, where n is the number of electrons. Suppose we want to fill the electrons in the K shell. For K shell we take n is equal to 1. We will apply the formula 2 into 1 square. It will be equal to 2. So only 2 electrons can be present in K shell, not more than that. For L, the value of n is 2. We will apply this formula 2 into 2 square. 2 into 4 is equal to 8. So in L shell, 8 electrons can be present, not more than that. So on this basis, you can find the number of electrons present in each of the shell. Okay, so for your knowledge example, I have also provided over there that in K shell the value of n is equal to 1. 2n square formula you will apply, and you can see that 2 elements can be present in the first shell. So in first period, how many elements are present? Only 2 elements are present in the first period. Now if we take the example of L shell, 8 electrons are present. Okay, in L shell always 8 electrons will be present. So in second period, how many elements are present? 8 elements will be present. So accordingly, you can predict that in one period how many elements are present. Position of an element in the periodic table tell us about chemical reactivity. Valence electron determines the kind and number of bonds formed by the elements. valence electron, they play a very important role for the elements. Its properties, the properties of the elements depends on its valence electrons. Correct? Now the most important topic which we are going to discuss now is trends in the modern periodic table. From here lots of questions are asked on the basis, reasoning questions, application based questions are asked from here. The first trend which we will reading about is the valency. So what is valency? Valency is the combining capacity of an element. We have read that one line definition. The combining capacity of an element is called its valency. The valency of element is determined by the number of valence electrons present in the outermost shell of its atom. How many valence electrons are present in the outermost shell or in the valence shell? That will give you the valency of the element. And the definition is the combining capacity of an element is known as its valency. Correct? Suppose, let us take an example of sodium, atomic number 11. If we write its electronic configuration, it's 2, 8 and 1. One electron is present in the outermost shell. So what is the valency of the sodium? It is equal to 1. Okay. Like that for magnesium, atomic number is 12. Electronic configuration is 2, 8, 2. 2 electron in the outermost shell. The valency of magnesium is 2. So from the outermost electron or from the valence electron, you can easily tell about the valency of the element. Now, what is the trend of valency in the period? On moving from left to right in a period, the valency first increases from 1 to 4 and then decreases to 0. So when you move in a periods, we are taking the example of third period elements. From 1 to 4, the valency will increase, and after that again it will decrease to 0. Okay, so valency will first increase from 1 to 4 and after that it decreases to 0. What is the trend in a group? On moving from top to bottom in a group, the valency remains the same because number of valence electrons remains the same. So in a group, no changes will be there in the valency because in a group the number of valence electron is same. Suppose in group number 1 the number of valence electron is 1, so the valency of all the elements which are present in group number 1 will be same, that is 1 only. But remember that in a period, the valency first increases from 1 to 4 and then it decreases to 0. Next, we talk about atomic size. So what is atomic size? It is the radius of an atom. It refers to the radius of an atom. It is the distance between the center of the nucleus and the outermost shell of an isolated atom. Suppose this is the nucleus and these are the shells. Suppose this is the outermost shell. So the distance between the nucleus and the last shell is called the atomic size. Is called the atomic size of that element. So what is its trend in the period? On moving from left to right in a period, atomic size decreases. And what is the reason? Because of the nuclear charge. Nuclear charge increases and atomic size decreases. The attraction of the nucleus for the attraction of the electron of the nucleus for the electrons, it will increase, and because of that the nuclear charge will increase and the atomic size will decrease. Now, atomic size of noble gases in corresponding period is largest due to the presence of fully filled electronic configuration. If we talk about noble gases, they have the largest atomic size. Why? Because the outermost shell is completely filled. They are stable. In a group, on moving from top to bottom, atomic size increases. Why? Because number of shells increases. If on moving from left to right, in each and every element, one shell will increase and their atomic size will increase. That is the reason that when we move from top to bottom in a group, atomic size increases. Now we talk about metallic character. It is the tendency of an element to lose electrons. You know that metals can easily lose electrons and non-metals will accept electrons. So metals are present on the left hand side and non-metals are present on the right hand side. So in a period, when moving from left to right in a period, metallic character decrease because tendency to lose electron decreases due to increase in nuclear charge. When you will be moving in a period, what will happen? Metallic character will decrease. Metallic character will decrease because the elements cannot lose electron. Their tendency to lose electron decreases. But in a group, when you move from top to bottom in a group, metallic character will increase. When you move from top to bottom in a group, the metallic character will increase that time because the atomic size and tendency to lose electron increases. Atomic size also increases down a group and their tendency to lose electron will also increase. So when we move from top to bottom in a group, the metallic character will increase. Now let's talk about the non-metallic character. nonmetals are present on the right side of the periodic table, and the nonmetals, they have the property to gain electron. So it is the tendency of an atom to gain electron. Nonmetals are present on the right hand side of the periodic table, that we all know. So in a period, when we move from left to right, the non-metallic character increases. Metallic character decreases, but non-metallic character increases. Why? Because the tendency to gain electron increases due to increase in nuclear charge. And in a group, when you move from top to bottom, non-metallic character decrease because atomic size increases and tendency to gain electron increases. Okay, so see, you can see through a flow chart also, metallic character in a period it will decrease, but in a group the metallic character will increase. Just opposite trend is there for non-metallic character. In a period, non-metallic character increases, but it decreases in a group. Now we will be reading about the chemical reactivity. In metals, chemical reactivity of metal increases down the group because the tendency to lose electron increases. Means reactivity of the metals will increase. When we move from top to bottom in a group, their reactivity will increase because their tendency to lose electron increases. Right? For non-metals, the chemical reactivity of non-metal will decrease down the group because tendency to gain electron decreases. Okay, now let's talk about the electronegativity. It is a tendency of an element to attract the shared pair of electrons towards it in a covalently bonded molecule. Electronegativity means what? Attraction of electrons. It attracts the shared pair of electrons. It increases with increase in nuclear charge or decrease in atomic size. If the nuclear charge will increase, electronegativity will obviously increase, and if the atomic size will decrease, electronegativity will decrease. So along a period, what happens? Along a period, atomic electronegativity increases. Why? Because atomic size decreases, but down a group, electronegativity decreases. Why? Because atomic size increases. Nature of oxides. Metal oxides are basic in nature. Example, Na2O, MgO. They all are basic in nature. And non-metallic oxides are acidic in nature. Carbon dioxide, nitrogen dioxide, they all are acidic in nature. Along a period, the basic character of the oxides of the element decrease while the acidic character increases. If you move in a period, what will happen? The basic character of the oxides of the element will decrease. Means basic oxides, so the basic character of the oxides will decrease and the acidic character will increase. Basic character will decrease and the acidic character of the oxides will increase along a period. But going down in a group, what happened? Order is reversed and the basic character of the oxides will increase and acidic character will decrease. Okay, remember like this. Suppose if I will draw a flowchart for you all, you have to remember like this. Along a period, and this is for group, and let's take it for acidic oxides. So along a period, acidic character increases and down a group, acidic character decreases. If we talk about basic character, so down a group, basic character increases and basic character decreases along a period. Okay, so this was all about the nature of oxides. Metallic character and non-metallic character that I have told you. Electronegativity. Electronegativity, for that you have to remember that along a period electronegativity will increase and down the group, when you move from top to bottom in a group, electronegativity will decrease that time. So this was all about this chapter, periodic classification of elements. So in just 30 minutes we have completed this lesson. In short, we did the revision from this lesson. I hope you all have understood. If you want a detailed explanation, you can go to the playlist of class 10. Over there you can search this chapter, and very soon we are coming up with the new chapter and we will do the revision from the next chapter. Thank you for watching. If it's helpful for you, then please click on the like button and share with your friends also. And if you are new to my channel, then do subscribe it, and don't forget to click on the bell icon so that whenever I will be uploading a new video, you will get the notification for that. Thank you for watching.